Hello, I'm Doug Williams from the American Chemical Society. Today I'm going to show you a little bit about fats in milk and how to determine what kind of milk you're drinking. And this is going to involve a little demonstration with food colors and detergent. One of the things that detergents do is they help us mix fat and water, because if you've poured oil and water together, they don't actually mix. In fact, they separate. If you shake them really hard, it might get cloudy for a while, but eventually they separate again. And oils are kind of hard to remove with water, aren't they? So that's why you use soap and detergents. But did you know that milk has fat in it and it doesn't separate? You probably wonder how they do that. Well, they pass the milk from the cow after it's been milked into what's called a homogenizer. It's a very small hole with a lot of pressure, and it passes all the liquid through this jet, and it distributes all of the fat globules into very small particles. And once they're in these small particles, then they stay dispersed in the milk, and that helps high-fat milk taste very creamy. If you don't do that and you let the milk separate, the fat goes to the top and it can be skimmed off, and so you can have low-fat or skimmed milk. Well, we're going to do a little experiment with the detergent today and some low-fat and high-fat milk. And I hope you'll get to see the difference between the two. This is called low-fat or skim milk. And this is more than high-fat, actually. This is called half and half. So this is richer than even the whole milk that you would normally get in a gallon at the grocery store. This milk has extra fat in it. And that's to help you see the difference. Now I'm going to take some ordinary food color, which actually is water soluble and doesn't disperse very well in fat. So we're going to put a little drop of each color in both of the milks. And you don't have to be very careful about this. You can do this at home with all of these things yourself. You can put those colors anywhere you want. I'm just going to try and keep a similar pattern so that the conditions are the same in both of the bowls. And this is red. So now I have red, green, blue, and yellow in each of the milks. And the next thing I'm going to do, so you can see at the same time, is I'm going to dip a little Q-tip or cotton tip swab into my dish detergent here. This is just ordinary dishwashing, hand washing detergent. And I'm going to put it into my milk and watch what happens. Now notice the one on my left, your right side, and the one on the right. They're both showing some color distribution, which we call the dancing milk experiment. The one on the right's kind of slowed down though, and it has big broad streams of color that are dispersing in the water. On the left side, however, there's a little more activity and it keeps on going. Can you see it picking up now? Faster, faster. What a difference. On the right side, we see colors that are moving slowly and kind of spreading out, and it's pretty. But over on the left, we actually have a kind of dance going on. And this is the result of the detergent distributing the fat particles, because there are so many of them. The interface, or the surface between the fat and the liquid and the water at very microscopic levels, has a lot of energy associated with it. And when the detergent breaks that down, the energy is released in the form of these waves and patterns that you see. So if you didn't know what kind of milk you were drinking, you could try this experiment with a little food color and a couple of swabs and some dish detergent, and you could tell if your mom was giving you the good stuff or the low-fat stuff. Can you tell? I like high-fat milk, but some people don't, and some people would want to avoid that. Either way, you can choose, but you'll know the difference now. Thank you very much.